Hello, my name is Jana Fank, and I'm a research associate at the Institute of Automotive Technology at the Technical University in Munich. In this short video, I would like to give you insights in my research work, developing an HMI for cooperative drug overtaking maneuvers on freeways. Let's begin with a quick overview about the motivation of this work. Here you can see the daily routine on German freeways. A slightly slower vehicle up front creates a time problem for the truck driver. As a result, the truck driver overtakes the slow-moving vehicle to minimize the use of the second lane and impeding the flow of traffic. These maneuvers are characterized by their inefficiency, riskiness, and high potential for conflict between road users. In the future, overtaking maneuvers can be coordinated through the mutual exchange of relevant data using V2X communication technologies. For example, here the red truck can send a cooperation request to the surrounding traffic. If everyone agrees, in this case the blue car and the black truck, the truck driver in the red truck is provided with the optimal overtaking time and speed for a traffic and energy efficient maneuver. Therefore, the blue car increases and the black truck decreases their speed. To ensure the driver's trust in the system and the acceptance to cooperate, a human-machine interface is needed. Therefore, the determination of the optimal information in each respective phase of the maneuver is crucial. It needs a clear definition of the tasks of the system and the steps to fulfill. And the instruction must be comprehensible and concise to reduce most confusion and mental stress. The aim of this research is to design an HMI for the assistance of cooperative truck overtaking maneuvers. Therefore, 3 research questions were formulated. First, how could I for cooperative truck overtaking maneuvers on freeways look like? How do truck drivers evaluate the acceptance of and trust in such a system? And what information does the truck driver need to successfully execute a cooperative overtaking maneuver? As an overall method, a user-centered development process is used to achieve the highest possible usability and user acceptance. It is divided into 5 development steps. First of all, to plan the design process, then to understand and specify the user context, the definition of specific user requirements, design the product to meet user requirements, and last but not least, to evaluate against the design requirements. Every step is looped through several times until the needs and requirements of the user are met. The user context was determined through a driving simulator study with truck drivers, and specific user requirements were identified through qualitative, semi-structured interviews with truck drivers and online surveys. In this approach, the results from the previous investigations are used to design an HMI concept and to evaluate it within 2 iteration loops. Let's begin with the HMI concept and the first iteration. In the first iteration, truck drivers were asked to categorize the information content collected from the previous studies according to the individual states of the overtaking maneuver. As method, a closed card sorting was used. The interview were transcribed and analyzed, and 5 key information categories were identified. Activation, for example, the system is on or off. Status, for example, cooperation confirmed. Instructions like in 250 meters, please change the lane. Requests like the sending a cooperation request. Cooperation partner, for example, the distance, velocity, or performance rate of the cooperation partner. Based on these findings, an HMI concept was developed in compliance with the standard design recommendations. You can see here the sketch of the instrument cluster, for example. After the first concept and design of the HMI, an evaluation by 5 HMI experts was conducted to reveal usability problems of the HMI concept. For evaluation methods, thinking aloud and heuristic evaluation was chosen. After another revision of the HMI concept, what you can see here, the concept was implemented within a graphical user interface embedded in a driving simulator cab. In the second iteration of the user-centered development process, the HMI concept was tested in the driving simulator study with truck drivers. The truck drivers rated two versions of HMI with different information content and confirmation process for cooperation requests. Therefore, two hypotheses were formulated. The first hypothesis means the representation of the surrounding traffic influences the interaction between the driver and the system. And the second, an automatic confirmation of a cooperation request influences the driver's acceptance according to the system. In order to compare different HMI concepts, a within subject design was used. As you can see here, the truck drivers had to pass two sections in the study. In the first section, the truck drivers evaluated the HMI concept from the perspective of overtakers. In the second section, they evaluated the HMI concept from the overtaken perspective. In both perspectives, the truck drivers faced three concepts. A baseline version in which the truck drivers were supported by the cooperative system, but no HMI was displayed. Then two versions in the overtaker perspective, in which varies the display of the surrounding traffic. And in the overtaking perspective, two versions in which the confirmation of a cooperation request was varied. The analysis of the driving behavior reveals the weakness of the HMI in the overtaker perspective. Only 30% of all overtaking maneuvers, the truck drivers followed the instructions of the HMI. Analyzing the answers of the system usability scale questionnaire, the HMI resulted in a usability score of 66 for the static version and 70 for the dynamic version. This means that the evaluation of the usability of the HMI missed the acceptable range. The evaluation of the acceptance rate from the overtaking perspective shows that the truck drivers would like to be asked prior to the system cooperating and ultimately reducing the vehicle speed. If we look again to the hypothesis, this means that we have to reject the first hypothesis since no significant differences could be measured. However, the second can be retained as significant differences were found here between the manual and automatic acceptance of a cooperation request. To sum up the results, we can say that the representation of the surrounding traffic is not really necessary. The HMI in the perspective of the overtaker needs definitely a revision, and that the truck drivers want to confirm cooperation requests manually. This brings me to the end of my presentation. I would like to summarize the content once again. V2X communication can improve the efficiency and safety of truck overtaking maneuvers on freeways. The success of such a system depends on the HMI. In this approach, an HMI was developed within a user-centered design process. The results indicate that truck drivers are willing to use such a system and that the HMI can support cooperative overtaking maneuvers. However, in the next development step, the interaction and information presentation need to be improved. So this is the end of my presentation. Thank you very much for your attention. If you have any questions, don't hesitate to contact me. Here at the end, you can find my references. Again, thank you and goodbye.